What do you call an urgent message sent across a parallel network? A parallelogram. Do you get it? And that is what we are studying today, and I hope you do get it when we go over the properties of parallelograms. And again, we're kind of looking at this Freyer model to help us organize our thoughts. And the first thing that I've been starting with, if you look at the parallelograms on the left, lower left here, I've usually been saying if they are concave or convex or neither. Well, you can see that all of the parallelograms on the left are actually convex. So it does have to be a convex quadrilateral, which is why this parallelogram, well, it's not a parallelogram, this quadrilateral is concave. So that one does not qualify as a parallelogram. Additionally, parallelograms must have two pairs of parallel sides. Usually the marks you'll see for parallel sides look like little arrows pointing in the same direction. And we'll put two marks when they're a second set of parallel sides, kind of like we did two marks for a second set of congruent sides. And you can see all of these figures here have, on the left, all these polygons have two sets of parallel sides. This trapezoid here has only one set of parallel sides, so only one set of parallel sides. And that looks like an 11, I know. Now the other thing is that opposite sides are congruent. And you can see these hash marks right here. On my rectangle, I have a congruent mark on top. And there are two, they didn't come out very large, congruent marks on the sides. My square, it actually has all four sides are congruent. Does that count for having opposite sides congruent? Yes, it does. Additionally, opposite angles are congruent. So you can see on my rhombus down here, which is a parallelogram, it does have opposite angles congruent. And also this other more traditional parallelogram also has opposite angles congruent. And here for the rectangle and the square, they all have 90 degrees, so the opposite angles are congruent. Whereas over here, I can have some opposite angles congruent here, but it's only one set of opposite angles for a kite. So it's only, and there's no parallel sides, so that's the real reason this doesn't work. No parallel sides. Alright? And additionally, consecutive angles are supplementary. For the rectangle and the square, that's easy to see because you have 90 degrees in each angle. For these other shapes, it may not, well, if you remember the same side interior angles, if this line's parallel to this, so let me get a highlighter. If the lines are parallel, then the transversal creates same side interior angles. So let's say I use those two lines right here. Then my transversal, it can be the bottom or the right side. And let me get a different color. So say my transversal's right here, that creates a pair of same side interior angles. Same side interior angles are always supplementary. So that is, and that's also true for the other side. So the consecutive angles are always supplementary. And the diagonals bisect each other. So I went ahead and drew some diagonals to make it even more marks on my drawing. So let me switch back to my pen. And if you look at the diagonals, it says they bisect each other. What does it mean? Bisect means that they cut each other exactly in half. Now, this set of diagonals, you can see, this set has one short diagonal and one long diagonal. So when it cuts it in half, the long diagonal's in two longer segments and the short diagonal's in two smaller segments. So you can see that diagonals do not have to be congruent. And additionally, they don't have to be perpendicular. If you look at this lower one, these two diagonals, sets of diagonals look pretty close in size, but they definitely don't meet at a 90-degree angle. This top angle here is more of an obtuse angle, and this smaller angle here is more of an acute angle. So they're definitely not perpendicular. Now, some helpful things to keep in mind. What are opposite sides? Well, opposite sides of a quadrilateral do not share a vertex. That means one of the corners on the quadrilateral. So, for example, down here I colored the opposite sides yellow. I could have colored the other side purple to match the bottom side. Additionally, opposite angles do not share a side. So if I look, this angle on the top right here is not an opposite angle to this angle down here. It only goes across the diagonal to be an opposite angle. Now here's an interesting thing. If adjacent sides of a parallelogram, they can be congruent. So in other words, that means that the side here and the side there, those are adjacent. They can be congruent. And when that happens, all four sides of the parallelogram are congruent. And that is given a special name. It's called a rhombus, R-H-O-M-B-U-S. Another special case is when all of the angles, adjacent angles of the parallelogram are congruent. Then all four angles actually have to be 90 degrees. Because if it's supplementary and they have to add to 180 and they have to be the same size, that makes them 90 degrees. And that type of parallelogram is called a rectangle. A square is a special case, and we'll get into that more in the next unit, or the next chapter, 6-3 and 4 and 5. Okay, so let's take a look at our first example. And this is pretty simple. We're just going to be using opposite angles and some of our parallel line information to find the missing angles in this parallelogram. So I'm trying to find x, y, and z. Well, I know that z is 53 because opposite angles are congruent. Angle z must be congruent to angle 53. I also can figure out y because I see a triangle here. If I go ahead and highlight that, go to a nice bright yellow, and you can see that I have a triangle right here. And that triangle, all the angles need to add up to 180. Well, I already know z is 53. The square here indicates that's a right angle, a 90-degree angle, and then I have y. So I say 53 plus y and plus 90 equals 180. I combine 53 and 90, and then I subtract 143 from both sides. And I get y equals 37. I can also figure out x because there's actually a pair of parallel lines here. Remember, opposite sides are parallel and congruent, so I'll just use a lighter color. So the pair of parallel lines are right here, and here's my transversal. This is an alternate interior angle right there, so that makes that a 90-degree angle, and I can find out that x is 90 degrees. Example 2, I have WXYZ as a parallelogram, and they want me to find the length of segment YZ and the measure of angle Z. So I'm going to use I'm going to use an angle relationship for one and a side relationship for the other. Let's start with the fact that opposite sides are congruent. So that tells me that this 6a plus 10 must equal 8a minus 4. I set up an equation with both values, and I solve for a. I have to isolate the a, and first of all what I do is I take away 6a from both sides. There are less a's on the left, so that's how many I take away from both. And I get 10 equals 2a minus 4. I don't want the minus 4 there, so to undo the subtracting 4, I have to add 4. Then I end up with 2a is 14 and 7 is a. Well, I'm not quite done. I need to find the length of YZ, which is this segment on bottom. So I go ahead and put 7 in for a, and I say YZ is 8a minus 4, 8 times 7 minus 4, 56 minus 4, that's 52. So that seemed like a fair amount of work, but it really wasn't that bad. Now I'm going to try and find the angles that are here. Well, if you remember from the previous, the first page, we said that adjacent angles are supplementary. So that means this angle W and that angle Z must add up to 180 degrees. So I say 18b minus 11 plus 9b plus 2 equals 180. When I combine like terms, I get 27b minus 9 equals 180. Add 9 to both sides, I get 27b equals 189, and b is 7. But I'm trying to find angle Z, so I have to substitute in 7 for b. So I have 9 times 7 plus 2, or 63 plus 2, and that is 65. For example 3, we're trying to find a couple of different segments here. So now I'm looking not so much as opposite sides being congruent, but the fact that the diagonals bisect each other. I am doing some opposite sides are congruent as well in this problem on the Z variables. But most of my work has to do with the diagonals. So first of all, I'm going to see the Kn and Nm. I'll just go in alphabetical order on the variables. X plus 6 and 2x minus 2, those have to be equal because the diagonals bisect each other, which means cut each other exactly in half. Solving for x, I subtract x from both, well, I'm going to go ahead and add 2 to both sides, and then I subtract x from both sides, and I get 8 for x. Well, I can go ahead and substitute that back in to find this piece, nm. So 2 times 8 minus 2, I get that from 2x minus 2. And 2 times 8 is 16, minus 2, and I get 14. Now I'm going to go ahead and find my y values. Again, the diagonals are bisected, so I have to set those equal to each other. 4y equals 3y plus 2. Here I only have to subtract 3y from both sides, and I get y equals 2. Now I can actually find JL. So first of all, I'm going to find JN and NL, and I find both of those are 8. Well, JL is both of those pieces put together, so 8 plus 8, that's 16. Now I'm going to pay attention to Z, and this is opposite sides. Opposite sides in parallelograms are congruent, so I need to set those two values equal to each other. 8Z plus 4 equals 16Z minus 4. And trying to isolate the z's, I subtract 8z from both sides, and I get 4 equals 8z minus 4. The reason is 16z minus 8z is 8z. Then I have to add 4 to both sides, and I get 8 equals 8z, which means z is 1. Now I can find LM right here and JK, this segment. So we'll start with JK. 16 times 1 minus 4 is 16 minus 4, or 12. Here I have 8 times 1 plus 4. 8 times 1 is 8, plus 4 is 12. So our answer for the length on this side is 12. And that makes sense. JK should be exactly the same size as LM. I actually didn't have to calculate them both. In our last example, it's not unusual to see a question asking you to find another point to make something a parallelogram. One thing to keep in mind is that parallelograms, when they name these vertices, they are in order. So those pointers there, A will come, say we do that one first, second, third, fourth, right? So I'm going to go ahead and plot point A, and it is at 2, negative 6. Then I plot point B, it's at negative 1, 2. Then I go ahead and plot point C at 5, 3. And I can connect the dots with a ruler, and I have half of my parallelogram. Now point D should go somewhere here on the lower right, but I'm not quite sure. But the nice thing is that parallelograms, opposite sides are going to be parallel. So I could actually look at the slope of one of these two lines. I'm going to use BC. And the line that's coming down here from A should use the same slope. So if I have the same slope here, I can just draw a line using that slope, and that is my new point D. And of course, connect the lines, and I have a parallelogram.